Hi, my name is Josue Botini. Right now I'm actually going to teach you a topic in math called derivatives. So now the first question you obviously all have is, what even is a derivative? What does that mean? Well, a derivative is basically, so you have the coordinate plane, right? And actually, instead of doing the coordinate plane, I'm going to do something different, more like a real life thing, so you actually understand it. So if you have a steep slope of a mountain, this very steep slope, and like you have a car driving down, sorry for my artistic skills, they're terrible, but so you have a car driving down the very steep slope, and they're like, hey, this is too steep to go down, so we're gonna have to pave off like some of the road, make it less steep. So, but how much are we gonna have to shave off the mountain? Well, they have to do it a little. See, they can't do it too much, otherwise they'll never get down. They can't do it not enough, because then it'll be too steep. So they have to just shave off the perfect amount, which in this case would be a tiny bit. That's actually a derivative. So the derivative of the slope, which is called the slope, say the slope is equal to, 5 meters. It's tiny, but, and then they have to make it 4.8 meters. So that 0.2 meters, that is the derivative. So now, let me teach you something called the power rule. So what even is the power rule? So I'm just gonna make a little box over here to show you what the power rule is. And the power rule. And the power rule is basically the derivative of any x to the power of n. And the derivative notation is this, d over dx. So the derivative, or d over dx, of any x to the power of n is equal to nx to the power of n minus 1. So I'll start this because that's where I left off. Okay. So that's basically the power rule, and I'm going to give you some examples. So you have the derivative of any x squared, not any z. What's that going to be? Well, we found out that this is the equation. So what is n? What is n in this equation? Well, n is just the exponent. So the exponent in this case is 2. So that means it's 2x to the power of n minus 1. N is 2, so we do 2 minus 1. And that is equal to 2x to the first power. But I'm not going to write that down because that's the simplified version is 2x. So great, that's actually an example, but I'm going to give you like 1 or 2 more examples. So let me just erase this quickly so I can have more space, sorry. And so we have the derivative of x cubed. So what is that equal to? Well, that is equal to, first we have to find n in this case. N is the exponent. Exponent is 3. It's going to be 3x. The power of n minus 1. N is 3, 3 minus 1. But 3 minus 1 is equal to 2. So it's 3x to the power of 2, 3x squared. Now I'm going to give you one last example. Just a little more tricky maybe. Now the derivative, how about the derivative of x to the n plus 1. What's that equal to? Well, first, of course, we have to find the exponent, which is n plus 1. So it's equal to parentheses n plus 1 multiplied by x to the power of n minus 1. Wait a second. Is it n minus 1 or just n? Because plus 1 minus 1 is equal to 0, and plus 0 is just n. Well, we're just going to treat this not as two numbers, not this variable n plus 1. We got to treat it as one whole number, n plus 1. Kind of like we treat fractions versus we treat ratios. So it's actually n minus 1. So n is equal to n plus 1. So n minus 1 would be equal to n plus 0, which is just n. So that means it's equal to n. And that is derivatives for you guys. See you on the next time.